Welcome back. So, wildfires. Why do they occur in some places, but not in other places? Why does it seem so common for wildfires to occur in the West, Arizona, California, etc., but you don't often hear too many wildfires central or eastern U.S.? Why is that the case? Let's talk about it. So, considering those things, what environmental factors do you think could shape the behavior of a wildfire, either how it starts or how it lives and breathes? What sort of factors, environmental factors, could shape the behaviors of a wildfire? Interesting question to ponder. Well, there's actually three main factors. The three factors that help to understand and predict wildfire behavior are fuel, topography, and weather. All right, fuel, the stuff that burns. Topography, the terrain. Is it flat? Is it mountainy? Weather. Is it a moist environment, dry environment, hot, cold, windy, not windy, etc. So let's talk about fuel. So fuel is the stuff that burns. Leaves, twigs, decaying material, grass, shrubs, trees, whatever. Or houses, fire, electrical poles, whatever it may be, vehicles. The size of the fuel affects ignition and movement. For example, the smaller so if you think about when you build a campfire, if you've ever built a campfire or a fire in your backyard in a fire pit, do you start off by lighting the big log first? Is that the very first thing you light? No, you're usually lighting something very small, a little newspaper, little twigs, little grass, little dried up needles, little small stuff that's going to ignite kind of quickly. So fuel size affects ignition and movement. So in order for a wildfire to get started, if all you have is big giant trees and nothing small to burn, well, the chances of a fire getting going are very small. But if there's a lot of little stuff around, little leaves, little twigs, all stuff on the ground, that stuff can ignite quickly. So fire size affects ignition. Fire in that kind of material can move very fast. Fires in big trees tend to move rather slow. It takes time for those things to catch fire. So again, fuel size affects ignition, how it starts, and movement, how fast it moves. So topography, so the terrain. Well, topography is actually somewhat tied into weather and or climate itself. Here's what I'm saying. Drier fuel that burns more easily are found on southern-facing slopes in the northern hemisphere. So if you have, let's say, a mountain or a hill, and one side is facing south, which faces the sun in the northern hemisphere, that's where we are, north of the equator, versus a side of the hill that faces north, away from the sun. Well, the south-facing slope is exposed to the sun. It's going to typically be warmer, heat up, going to be drier, but there also might be more vegetation, more sunlight, more vegetation. So depending on how much or how little rain there is as well, that's another factor. But in general, south-facing slopes, again, they're exposed to the sun in the northern hemisphere. South of the equator, that would be the opposite, so north-facing slopes. But again, the material is going to be warmer, it might be dried out, but there also might be more of it because it's facing the sun. The side of the hill or mountain facing away from the sun, well, less sun, less plants, but also less heat, less dry, etc. You're also going to get fuels that burn more easily if a slope is facing into the prevailing winds. Thinking back to last unit on weather and climate, or a couple units back, wind moves different directions on different days, but overall there's a prevailing wind pattern, and those are different. It depends on where you're at in the world, not only in the U.S. but where at in the world as well. But if a slope is also kind of facing the wind, so if it's facing south, the sun, and that's the prevailing wind direction, that is aiding in drying out the material. Mountainous areas tend to circulate winds up canyons during daytimes and actually down canyons during night times. So that helps to circulate wind. So wildfires, tend to thrive in kind of more mountainy areas. They're typically more windy anyway. They don't too often affect very flat areas. It's not that they can't. It's just swirling winds. You have the slopes exposing in drying materials to the sun. So a lot of hilly areas, that's where you're going to tend to find more wildfires. Again, not that you can't in flat areas. It's just the topography really aids in all of that. So as wildfires kind of move uphill, up a slope, they kind of preheat the fuel because, again, remember back to that unit on weather and climate, hot air rises. So if the fire is heating up the air and it starts at the bottom of the slope, that hot air is kind of rising up. That hot air is drying everything else out. So it really preheats everything moving forward and starts to dry things out, heats things up, and the fire can spread much easier and move much faster. So the topography plays a big part. And then, obviously, weather, definitely a dominant influence on wildfire, looking at temperatures, precipitation, or lack thereof, relative humidity, which is a measurement of how much moisture is in the air. Here in Phoenix, we always talk about our dry heat. When we're saying that, we're saying there's no moisture in the air. There's no humidity. So humidity, again, a measure of how much moisture is in the air. If you're in an area with a lot of humidity, high humidity, well, a lot of moisture in the air, then plants are tending to be more moist as well. Sorry, I had to use the word moist. But the lower the humidity, the drier the atmosphere, the drier the environment. So temperature, precipitation, or lack thereof, how much or how little humidity, and wind. All of that weather factors go into the starting and movement of a fire. Fires are obviously very common following droughts, hot and dry. Wind direction and strength really helps to preheat unburned materials. Again, thinking back to like slopes and hot air rising, kind of starting to heat up the vegetation as that hot air is going up the mountain slope. But winds also can carry small little embers and ash from the fire itself to ignite what's called a spot fire ahead of the fire that's already moving. So wind, not only does it fuel the fire, but it also can help start more fires, little fires that eventually all meet up to form one big fire. Now, that's kind of the environmental factors in general shaping and creating wildfires. But due to climate change, in areas of the country, the hotter is getting hotter, drier is getting drier. It's really increasing the intensity and frequency. So not only are there more fires, they're burning hotter and longer. So they're becoming bigger. Changes in temperature and, again, precipitation and frequency and intensity of severe storms. So increases in temperature, decreases in humidity. Again, if it's getting hotter and it's getting drier, that's just going to make vegetation more easily dried out, making it more fuel for wildfire. Excuse me. So there, in areas, in general, climates that are warming up, typically, in the cooler environment, you tend to have your forest type ecosystems. Well, as those areas kind of warm up, well, forests thrive in colder temperatures, so if an area is becoming warmer, then the forests are going to die out, and they're being replaced by, grasslands and shrubs, and that stuff burns very easily. It dries out very easily, burns very fast. So if that's the case, then lightning strikes are really going to increase ignition in areas affected by climate change. If a lot of places are getting hotter and drier, it doesn't even need to be a human caused. In fact, we'll talk about what creates wildfires here in a section or two. But it's really two main factors: humans or lightning. So, but in general, if we're drying out the environment, if we're creating these mega droughts in these just areas that are hot and dry, lightning will just set it off very easily. So, there are many statistics you can look at to see climate change in action, and this is just one of them. So this is the annual number of acres burned in wildfires in the past 40 years in the United States. And so from 1980 to 2020, again, this is acres of burned. So how much land area has been burned. And you can kind of see, yes, there's up and down, up and down, up and down, but in general, the trend, there's more acres being burned. More area is being burned because more area is drier because of climate change. So this is just another one of those unfortunate graphs that shows you acres in the amount of millions of acres that are burned. All right. Let's pause here, and when we'll come back, we'll talk about some of those causes of wildfires, lightning, humans, etc. I'll see you back here in just a second.